This video lesson is on decimal division. I've solved six problems, more explanation at the beginning, less at the end. The focus on the last three is solving problems that have decimals in the divisor, and it's about solving equivalent problems and avoiding those messy decimal jumps that students often make errors on. I encourage students to solve problems along with me, so doing a lot of pausing and restarting so that they're actually getting the practice in and not simply watching the work being done before them. So in this first problem, 343 divided by 5, when we write it as a division problem, we need to think about how it's written. So it's 343 is our starting amount, and we're going to be dividing by 5. So the first question is, how many times does 5 go into the first digit of 3? Really, that 3 is 300. So how many 5s in 300? We're going to shorten that up and just look at 5 times 3. And there are 0. I could put a 0 up here, but I'm going to skip that. If you feel comfortable putting a 0 up there, go ahead and do that. So now I need to increase my number, 34, which is really 340. So how many 5s in 340? But I'm just going to think about the first couple digits and think of that as being 34. So 5 goes into 34 6 times, so I'm going to record a 6 up there, and I'm thinking 5 times 6 is how many I can take out. That's a total of 30 that I can remove. So I'm going to take those away and record the 4 that remains, the difference between those two. So I was able to go in there 30 times, and now I have 4 left over. And now I'm looking at not 5 going into 4, but I need to consider the rest of my number, because this number should always be less than your divisor. If it's more than your divisor, it means that you can take more of these out and you're not quite done. So I need to bring down that 3. So now I'm thinking of 5 goes into 43. I know that 5 times 8 is 40. So I'm going to put an 8 up here. So my thinking, 5 times 8 is 40. And I record the difference. There's going to be 3 left over. Initially, we described that as a remainder of 3. So we would say that 343 divided by 5 is 68 with a remainder of 3. But we're at the point where we have moved beyond that. So we see that we have more that we can divide. So we add a decimal at the end and a 0 behind that. We can add an infinite number of zeros. We only need 1 at this point. So we would bring our decimal up above as well into the quotient, and we bring that 0 down. 5 goes into 36 times, so we record the 6. 5 times 6 is 30. We take out 30 from the 30 we had, and we're left with 0. Now that we have a 0 at the end and there's nothing else that we need to bring down, now we can say that we are done, and our final answer, 343 divided by 5 equals 68.6. So there are 68 and 6/10 5s that we can take out of 343. So on this next problem, 235 divided by 3, when I write it down, 235 divided by 3. I question 3 going into 2, 0 times. So now I'm looking at 3 going into 23, and it goes in there 7 times. So my thinking would be 3 times 7. I'm just going to write the 21. Do the difference. 23 minus 21 is 2. I'm going to bring down this 5. Now I'm questioning 3 going into 25. I know 3 can go into 25 8 times. So I record my 8. Find the difference. 25 minus 24 is 1. So it's 78 with a remainder of 1, but I'm going to continue instead of having a remainder. Add my extra 0, infinite number I could, I just need 1 at a time. Don't forget to put the decimal up in the answer, because it's going to be 78 in some fractional amount. Bring down that 0. So now 3 going into 10. 3 goes into 10 3 times. And my thinking 3 times 3 is 9, so I can take 9 away from out of the 10, and I end up with 1 left over. I just noticed that that's how much I had left over before. Interesting. So if I put down another 0 and bring that down, well, now I have that 10. And I know that 3 goes into 10 3 times. I've seen that before. And I get a 1 again. So I have asked students to indicate the repeating by showing that it repeats twice. So I'm noticing a pattern here, and it's not really a pattern if it happens only once. It's a pattern when it happens more, 2 or more times. So it's repeating, so what that tells me is that I would have an infinite number of 3's. If I keep subtracting 9 and finding the difference, I get 1 every single time that's going to happen. So my final conclusion is 235 divided by 3 is 78.3, and that 3 repeats. And it doesn't matter how many 3's I write, I just need to have at least one 3 with a repeat bar over it. We have talked in class about how that would also be a fraction, but we're going to focus on decimals in this lesson. Okay, so looking at the problem, 235 and 4/10 divided by 4. So when I write it out, 235 and 4/10. So this is the first problem that's had a decimal value already, divided by 4. So now I'm questioning, whoops, put that back. 4 goes into 23 how many times? Well, 4 times 6 is 24. That's too many, so it's got to go in there 5 times. 4 times 5 is 20. Take away the 3, bring down the 5. So now questioning, 4 goes into 35 how many times? I believe it goes in there 8 times, because 4 times 8 is 32. Find the difference. Difference is 3. And I noticed I had 3 last time, but instead of the 5, this time I'm going to have a 4, so not repeating. So now 4 goes into 34. Well, it goes in there another 8 times, just like that one. Oops, and I need to remember to put my decimal up on that answer. So I'm going to put another 8. I record the 32. I have 2 left over, and I need to add a 0 to finish the problem. Bring that down, and 4 goes into 25 times. When I subtract, I have 0, and I am done. So the conclusion to my problem, 235.4 divided by 4 is equal to 58.85. So there are 58.854's in 235.4. So this next problem, 523.2 divided by 0.8. Now this is the first time that we've had a problem with a decimal value out front in the divisor, and I've told the students dividing by a number with a decimal is really challenging. So this is a problem that I have identified as being a yuck problem. So we're going to look at how we can solve it without doing that yucky problem. So in class I showed them that if we have a number like 6 divided by 3, which is 2, if we scale this up, both of them by the same factor, multiples of 10, which affect place value, we end up with 60 divided by 30. And 60 divided by 30 is still 2. The problems are different, but they are equivalent. They give us the same result. So we can revise this problem by scaling it up by multiples of 10 so that we can avoid that decimal. So back to this original problem, my divisor is in the 10th position. If I have 10 of those, then the place value switches them to the ones place, because every time we have 10 of one thing and we increase place value to the next. So if I multiply this by 10, I get a divisor of 8, and that is much more desirable. If I multiply this value by 10, that 2 at the end becomes in the place value of the 2's, and everything shifts over a place value. So I end up with 5,232 divided by 8 is my equivalent problem. So that's the problem I'm going to solve. 5,232 divided by 8. And 8 goes into 5 0 times. 8 goes into 52 6 times. 8 times 6 is 48. When I do the subtraction, so I'm thinking 8 goes into 12 4 times, with 3 as my bring down number. 8 goes into 43 5 times. 8 times 5 is 40. So I can take out 40 from the 43, and I have 3 left over, and my bring down number is 2. 8 goes into 32 exactly 4 times. So I can take out all the 32, and I am done. So my final conclusion, 523.2 divided by 8/10 is equivalent to 654. Now, if there is an adult out there wondering why I would do it this way instead of moving the decimal, it just makes for a cleaner problem. It solves an equivalent problem. It's very mathematical, and I want students to be thinking about multiples of 10 and how that affects place value, because that is an important thing that they understand. Okay, on this particular problem, the divisor has numbers in the hundredths. So if we multiply by 100, that'll move 2 decimal spaces over 2 groups of 10, 2 place values, and allow us to have a number that is a whole number. So if we multiply one of them by 100, to scale up the other one, we have to also multiply it by 100. So the decimal moves over 2 place values. So from in front of the 5 to behind the 5 and another 0. So the tenths become in the tens place. Oops. And the 400ths becomes 4. So this is the problem that we will end up solving. So 4 on the outside, so 62,450 divided by 4. So 4 goes into 6 one time, with 2 left over. Bring down the 2. 4 goes into 22 5 times. 4 times 5 is 20, with a difference of 2. 2 left over. We bring down the 4. 4 goes into 24 6 times, which takes all of the 24. But we still have to bring down a 5. We're not yet done. And 4 goes into 5 one time, with 1 left over. So bring down the 0. And 4 goes into 10 2 times. And 4 times 2 is 8, with 2 left over. So now I have to, I'm not done, add a 0. Continue on. And 4 goes into 20, oops, I'm going to add my decimal, 5 times, with 0 left over. So now I am officially done, nothing left to bring down that has to be brought down. So my final answer, 624.5 divided by 4 hundredths is 15,612.5. When I'm taking out a very small portion, I want to know how many of these really small values are in here. I'm expecting a lot more. So in this last problem, I have a decimal divisor of 3/10, and the number that I'm dividing that into, how many groups of 3/10 are in this 625.25, that number's in the hundredths. Now, it doesn't matter really what the decimal value is here. I can deal with any decimals in my dividend. It's the divisor that I'm looking at, the number that I'm dividing by. So I need to focus on this value here, and I only need to multiply by 10 to move that decimal, or to move the place value, so that I end up, instead of 3/10, I have 3. So I only need to multiply this by 10 and affect one place value. The decimal will move one place value over. So I end up with 6,252 and 5/10. So that's the problem that I'm going to solve. So 6,252.5 divided by 3 as an equivalent problem. So 3 divides into 6 2 times. 3 times 2 is 6. The difference is 0. 3 going, I have to bring down my 2. 3 goes into 2 0 times. Now if you want, you can do the math, but you really don't need to. You can just bring down that 5 at any time. So now I'm looking at 3 going into 25. 3 goes into 25 8 times, because 3 times 8 is 24. I'll do the subtraction, bring down my 2. 3 goes into 12 4 times, 0. But I'm not quite done. I still have my decimal. I'm going to go ahead and put my decimal up here so I don't forget. Bring down my 5. 3 goes into 5 one time, excuse me. Oops. One time with 2 left over. And I'm not quite done, so I have to stick on a 0 there. Continue on. Bring down that 0. 3 goes into 26 times, which is 18. I think I need to make it smaller again. With 2 left over. Not done, so bring down another 0. And 3 goes into 26 times again. I just had that one. And 2. So now I've established a pattern. So a pattern of repeating. So once I have a pattern of repeating, I can say that that 6 will continue to repeat. And my final conclusion, 625.25 divided by 3/10 is 2,884.16, and the 6 repeats. That is it. Thank you for watching.